Alright, so this is going to be your first video that's going to be pushing the 7-minute limit, just to kind of give you a heads up as to what's coming with regards to this. This is an official, here you go, taking notes while you're following along as we go through this. Alright, the topic for today is going to be the consequences of warmer oceans. So this is going to hit everything that's found within E5.4-13, which is basically talking about the evidence that has been collected over the course of history regarding climate models that have been created. And the whole idea is for you to be able to explain what happens when the oceans become warmer. And the four things that I'm going to ask of you, and actually I take that back, there's going to be five. Can you explain exactly what happens when there's an increased amount of evaporation within our atmosphere? Second, what happens when we have warmer oceans? What does that do to our shorelines? And also, what does that do to our estuaries? And then the final two, which are actually linked together, is what happens when we have warmer oceans to oceanic algae growth, which is linked directly to coral, and what happens when warmer oceans actually come in contact with coral, and that is simply called coral bleaching. So we're gonna go through all five of these over the course of our notes, and let's go ahead and get started. All right, so the notes: consequences of warmer oceans. What I'm going to point out to you while going through this are some things that scientists have actually picked up along the way over the course of the last 150 years as they've been recording things that have been taking place in our oceans. The first is this, okay? What's the big deal if we have 1 degree Fahrenheit? So we're talking 1 degree. Do you really know what the difference is between 58 and 59 degrees Fahrenheit when you walk outside? Probably not. But what is the big deal? That's what we're going to be focusing on. The big deal is, it is a big deal, because what we can do is we can actually look back at our history to see what has actually taken place. And the things that we look at are, first, tree rings. The second are ice cores. We go up both north, south, and we drill into the ice to see exactly what has been recorded within our atmosphere. Third, coral reefs. Great place to look to see exactly what's happening with our oceans. So, the global average temperature has been stable. It's been the same for so many years. The problem is any small changes in the temperature causes a huge change within our environment, and more specifically to certain habitats that are found within our actual environment. So it's an enormous change, and we'll talk about how enormous that is. So, for example, when we had our last ice age in the northeast portion of the United States, okay, so we're talking like New York area, Vermont, Maine, the northeast portion of the United States, 3,000 feet of ice was covering, and the temperature was only 5 to 9 degrees cooler than it is today. So when you're talking about global averages in temperature, 5 to 9 degrees cooler represented 3,000 feet of ice. So imagine yourself being covered with, 5,280 feet is 1 mile. You're talking over a half a mile of ice sitting on top of you because the temperature was 5 to 9 degrees cooler. So the consequences, there are 4 that we're going to talk about, and actually there are 5 because both of these two right here, estuaries and shoreline, kind of go together, but also are separate, and I'll talk about that in a little bit. So we're going to talk about the 4: increased evaporation, shoreline and estuaries, and then we'll split them. Oceanic algae growth, which is also connected directly to this, which is coral bleaching, and we'll talk about how they are intertwined and go together. So let's start with the first one: increased evaporation. When anything becomes warmer, and this is a perfect example of living in Michigan, when it gets warmer outside, especially during the summer, what happens to your hair, girls? Guys don't really have that problem. Some might, but for the most part, it's mostly a girl problem. You notice that your hair starts to wig out, right? You get this problem with, all the frizzies and things sticking out all over the place, and it's because of the humidity. You have a lot of moisture in the air mixed with warmer temperatures. So when the oceans become warmer, the amount of moisture that enters into our atmosphere, it increases. It goes up, which, again, the girls pull it back, put it in a ponytail, spray it down so it doesn't just wig out on you, right? So there's one in problem with the oceans. It increases evaporation. When that happens, when you increase more moisture and put it into our atmosphere, we put more clouds into the sky. Clouds are examples of when you take moisture and you condense it. You start to actually bring it back into a liquid state, and clouds are just that example. And when you increase more moisture, you increase more clouds, and when that happens, it then leads to this problem. What happens is clouds have the ability to and not allow it to go back and escape into space. So it kind of plays the double-edged sword, because one, it's helping because it's reflecting some of the radiation, but two, it's also not allowing the radiation that gets in to actually go back. And here's a diagram to explain that. You'll notice that some radiation, as you see coming in, makes it back to the Earth's surface and then gets reflected. The problem is, and it's right here, is that those clouds sometimes do not allow it to go back out. And sometimes as the radiation comes in, it will actually hit the cloud and then head back off into space. And then in other times, it will come directly back to Earth. So the clouds actually play a very key important role. President Bush, when he was in his first term, actually went on record talking about global climate change and saying scientists, more or less, are telling me that clouds are causing global temperatures to actually go up. And he said, how ridiculous is that, talking about clouds? But the more scientists have been studying this, they have realized that they act as like a blanket. They cover us. They help us to keep warm. And a perfect example of that is if you were to go home and wrap yourself in a blanket and you just lay still, you'll notice that your temperature is actually going to start to increase, okay, your body temperature. And that's exactly what clouds do. They insulate the Earth. But it also doesn't allow some of the heat to also get inside, where a blanket might allow that heat, especially if you put a heat lamp as an example, to get in. So it's still a science that we're looking at and studying. But the more we look at it, the more we research it, the more that we collect data on it. That's exactly what's happening. It's becoming a blanket, not allowing some to come in, but keeping those that are already in, as far as radiation, can't go back.